What I am doing is trying to do something a little bit different for this live stream. I typically am always going on YouTube, and I am trying to see if I can actually multi-stream this over to my Facebook page on the free math video. So I'll go ahead and check on that rather shortly. It seems like the stream life is a little bit low, and I'm not sure if that's because of the multicasting or not. So I'll go ahead and kind of check into it. But hopefully for those of you guys that are joining in, if kind of my first time being on the live stream, basically what I am going to do here is just kind of work through the homework assignment that I provided my students inside the class. And what we're going to do is just kind of work on our angles in trigonometry. So we're going to basically evaluate the 6 trigonometric functions given a point, evaluate the 6 trigonometric functions given a trigonometric equation as well as a constraint. And then what I'll do is I'll kind of take a little break if you have any questions over what I am covering. Or if you have any questions just in your general class, I'll take a little break and answer those. And then we'll go ahead and get on to the multiple choice. So let's go ahead and get on it. See Flippy and Guillermo, how you guys doing? I do got to ask, I'm not getting a full good stream health from my YouTube portal. So please let me know if you guys are getting any lag on that, or if you're getting some buffering, or if the sound quality is not going through, because I'm not getting it as a good quality right now. And I'm not sure if that's the internet on my side, or if it's because I'm also trying to push this over to my Facebook group as well and kind of see how that is working out. So just let me know if there's anything you guys have. I'll be more than happy to kind of like stop the stream and kind of repost it if I need to, but hopefully this will be all right. So you are very well. Pedro says not in your class. If I said notice me, LOL. Well, that's awesome. You came in from notification. That's, I always feel kind of bad before I get started here. It's, I always want to get my streams. And like yesterday, I was actually going to go live. But the problem was, that I forgot my equipment, at school. So I was going to do a late night live, homework session. Then I was like, crap, I left my microphone, my lights, the camera, everything was actually I have a camera at home, but, or my sketch pad was all at school. So I was like, all right, I'm just going to have to do a little double duty. So what that means is I'm going to do a live, stream today, and then I'll also be back tomorrow. So even if you forget the notification, I'll be back tomorrow. But, I don't want to talk too much. I want to get right into this, and then obviously I'll take a break and answer your questions. It says no lag, so that's good. Pigs Man Adventure, I will shout you out, man. Happy to be in the stream. And Jose Alberto, thanks for helping your college classes. You are very welcome, my friend. I am happy to be able to offer you guys any mathematical, help as you guys are working through, because I know, as I was working through working through my classes, I always had to rely on, tutors or other people to really make sure I can improve upon those skills. So, let's go ahead and get into this. If you are covering trig, that's awesome. If not, but you're coming up to it, I think this would be something that'd be great for you to obviously know for any kind of class in trigonometry or pre-calculus. So the first one says evaluate the 6 points. And basically, what I tell my students in this case is the first thing we want to do is plot the point. And so we plot this point. Now we plot this point. And basically, so far we've talked about the trigonometric functions are, based on triangles. So what we're going to want to do in this case is create a triangle. So we don't just want to create any triangle. We want to create a triangle that's going to have a central angle, basically going to be perpendicular with the x-axis, where theta is going to have a vertex at the origin. And it's going to be very, very important that when you are creating your triangles, that all of your triangles are perpendicular to the x-axis and have that central angle. And again, that's something that we talked about today, why that central angle is so important for us to evaluate the trigonometric function. So in this class period, we didn't really talk about it. We just kind of said, do it, it's important. But then it kind of makes sense as we kind of continue going through the lesson. So we know that this side length is -1, this side length is +1, and then if I want to be able to find the hypotenuse, I just go ahead and apply the Pythagorean theorem. And let's just we were calling this r squared, and so therefore this is 1 + 1, oops. Yeah, let's go and zoom in. So 1 + 1 equals r squared, and therefore if you solve, r is going to be the square root of 2. We don't need to worry about the plus or minus here because that's the hypotenuse, and the hypotenuse will always be positive. So I'm going to go ahead and put this in parentheses, just reminding myself that that is something I solved for. And now we have our theta here, and we're just going to do the 6 trigonometric functions. So remember, sine of theta is going to be opposite over hypotenuse. So that's going to be 1 over the square root of 2. And then we're going to simplify that by rationalizing the denominator. I'll do the first one, then I'm not going to do it anymore because if you've stayed with my channel or my students have seen me do this over and over and over again. So when I say rationalizing the denominator, I mean multiplying the numerator and denominator by the radical. So therefore we get square root of 2 over 2. And then the cosine of theta is going to be the adjacent over the hypotenuse. And what we notice here is, again, that's going to be the exact same as sine. It's just going to be negative. So I'm just going to quickly write that answer, negative square root of 2 over 2. And then the tangent of theta is obviously the opposite over the adjacent. So that's going to be 1 over negative 1, which is just equal to negative 1. Now let's get into the reciprocal identities, which is basically the reciprocal of sine, so the cosecant of theta, which is the reciprocal of sine. So that's going to be square root of 2 over 1, which is just the square root of 2. The secant of theta is going to be, again, the same, so that's the square root of 2. And then we'll look at the cotangent of theta, which obviously the reciprocal of negative 1, guys, is just going to be negative 1 again, right? Negative 1 over 1, which will be negative 1. So that's basically like the general idea we have. And obviously some of you might take some notice that these are some familiar numbers coming from our special right triangles, which is, again, something that we kind of continue to further investigate in our later kind of chapters, and something we've already kind of talked about in previous lessons. So let's go and work on another one. This point is at negative 2, negative 4. So if I was just going to go ahead and sketch that one, that's at negative 2, and let's go 1, 2, 3, 4. I won't make a triangle that's perfect. Let's do negative 2 right there. Oh, man, you know what? Fine. Not going to do it that way. Just redo it. So negative 2. I just don't want to do so small that I can't see it. Now again, we want to create our central angle, so we want our angle to be at the vertex to be at the origin, and we want this to be perpendicular. Okay, so there is going to be our angle theta. All right, and that's a horrible triangle, but that's okay. We can see obviously we're going to the x here, which is going to be negative 2, and we're going down negative 4. So now again, we want to use the Pythagorean theorem to find our hypotenuse. So it'd be negative 2 squared plus negative 4 squared equals r squared, which is representing our hypotenuse. And therefore this would be positive 4 plus 16 equals r squared. So I'll just write it, r squared equals 20. And then obviously if we're going to be taking the square root, again, we only need to be concerned about the positive value. However, we do want to make sure that we can simplify the square root of 20 into a simplified answer. And we could break that down into, let's see, that'd be 4 times 5, so that'd be 2 square root of 5. All right, and again, we've covered a lot of this, so that's why I'm kind of moving a little quicker. I apologize if you are just kind of like entering this video as far as like an introductory part. But simplifying radicals is something that, getting to this stage, we should have a general idea of what to do. All right, so let's go ahead and get into our trigonometric values. So now I have... I know what the hypotenuse is now, which is 2 radical 5. All right, so the sine of this theta is going to be opposite over hypotenuse. So that's a negative 4 over 2 square root of 5. So in this case, there's a couple different things we're doing. We're taking the 2, dividing it into the negative 2, and then I'm going to rationalize the denominator. So when I take negative 4 divided by 2, I still have a negative value, right? But it's going to be 2 in the numerator. When I rationalize the denominator, I'll be left with the square root of 5 over 5. I don't like that 5. And the cosine of theta is not the same as it was in here. This was a special relationship. So in this one, we're looking at the adjacent over the hypotenuse. So it's going to be negative 2 over 2 square root of 5. In this case, you can see that the 2's are going to divide to negative 1. So that's going to give me a simplified answer of negative 1 times square root of 5, which would just be negative square root of 5 over 5. Okay, and again, this is a homework assignment, so that's why I'm kind of doing a little bit, not showing as much work, breaking it down, because we've already kind of covered this in the class. So hopefully, if you have some foundation with this, you can kind of follow along with me. The tangent in this one is going to be negative 4, which is the opposite over the adjacent, and that's just going to simplify to a positive 2. All right, let's do the reciprocals. Now, what's nice about writing the original, even though I'm not showing my work for the simplifying, I like writing the original here because all I got to do the reciprocal relationships is just flip the original, ratio. Because remember, if sine is opposite over hypotenuse, the cosecant is hypotenuse over opposite. So cosecant of theta is just going to be 2 square root of 5 over negative 4. Well, now 4 doesn't divide into 2, but I can reduce that to 1/2. So that's going to be a negative square root of 5 over 2. The secant of theta is just going to be the reduction here, which would be 2 square root of 5 over negative 2, which obviously you can see those divide out, so we're left with a negative square root of 5. And then obviously the tangent, if you were just to flip those around, or the cotangent, I'm sorry, that would just equal negative 2 over negative 4, which is equal to 1/2. Okay. I'll probably start with the next one, kind of working that a little bit faster. I don't know, maybe not. Probably still like to always kind of show my work, right? Kind of see where people are coming from. So, chat disconnected. Let's see how that's right through. All right, cool. All right. So the next one. Now, this one kind of gets a little tricky because we have this radical here, right? And it's like, where does this stand? Well, first of all, it doesn't really matter. We don't really care really what that radical is. Now, as far as like an understanding of like what value it is, we know that square root of 1 is obviously 1. We don't know square root of 2. We don't know square root of 3. But we know the square root of 4 is equal to 2. So these are going to be approximates, right? We're going to have to approximate somewhere between 1 and 2. And let's just use a decimal value of like 1.7, 1.6. Doesn't matter. So if I'm going to multiply that by 3, I know I'm dealing with somewhere, as a rough estimate, let's just use 1.5 as an estimate for square root of 3, just as a gauge. If you're multiplying that by 3, you're looking at like 4.5. So we're probably looking around the upper 4s, lower 5s as like an estimate. So I'm just using that just to get an idea of what I want my graph to look like. Because in this case, I'm going 3 units. And again, I'm not using a calculator. We don't have a calculator on this test or exam. So the only reason why I'm just doing it, just so I can kind of get an estimate, 1, 2, 3, 4. I'll just do like between 4 and 5, just so we can kind of idea. But again, it doesn't really matter what that point is, because we're still going to be labeling the triangles exactly. So you can see now we're going to create, again, our central angle. Again, notice that all of my triangles that I have all have central angles. I'll have the vertex at the center. And again, that's something very important that we'll kind of continue talking about next lesson. And then we have the right angle, which is always perpendicular to the x-axis. So we know this value is 3. That's not a 3. We know this value is 3, and this value is going to be a negative 3 square root of 3. So again, it doesn't really matter if I estimated it wrong either, right? If I used the calculator and found the exact answer, we still got to do the same work. We still got to apply the Pythagorean theorem to figure out what that side length is. So I'm just going to take 3 squared plus negative 3 square root of 3 squared, and then we'll call that r squared. So 3 squared is 9. Plus, now be careful with this one. This one gets a lot of students sometimes. Remember it's negative 3 square root of 3 squared, so you're multiplying by itself. So in this case, you have 3 times 3, which is going to be 9, and then times 3, which would be positive 27. And what we get here is 36 equals r to the 7th. And therefore, then what we kind of notice is, r is equal to 6. And again, we're only using the positive value here because it's the hypotenuse. All right. So there we go. There's our hypotenuse. So that's kind of nice, only having that one radical in for there. And now what we can do is let's just go and evaluate our sine, cosine, and tangent. So the sine of theta is going to be opposite over hypotenuse. So that's negative 3 square root of 3 over 6, and that reduces to 1/2. So therefore, that's a negative square root of 3 over 2. I have cosine of theta, which is going to be adjacent over hypotenuse, which is going to be 3 over 6, which is equal to 1/2. The tangent of theta, which is going to be opposite over adjacent, so that's going to be negative 3 square root of 6 over 6. That's not square root of 6, that's square root of 3. check that out. Okay, and then that reduces to a negative square root of 3 over 2. And then our reciprocals, man, I didn't really give myself a lot of space, but let's do it over here. Cosecant of theta, let's just kind of do this quickly, is just going to be the reciprocal here. So if I reciprocate this answer, I would have 2, or it's a negative 2. Let's write this as a negative 2 over radical 3, and if I rationalize the denominator, that's going to be a negative 2 square root of 3 over 3. And I already showed the rationalize at the beginning, so I'm not going to go back over that. The secant of theta, that one's pretty easy. That's just going to be 2, reciprocal of 1/2. And the cotangent, what did I do wrong? I did something wrong. Did anybody check it? I don't know if anybody said anything. Not seeing if anybody said anything. So let's see. Obviously, the sine and tangent are not the same. So tangent is going to be negative 3 over 3. That's where I made my mistake. All right. Oops. So those divide out just to give you a negative 3. So for my secant, so for my cotangent, that's just going to be 1 over negative square root of 3, which is going to equal a negative square root of 3 over 3. And kind of getting pushed all the way to the end, so hopefully you guys kind of got that one. I'll kind of zoom out here for you on that. So small I can't see it. Sorry, that's why I'm trying to zoom in here back so you guys can pick that up. So, all right, let's go ahead and work on number 2. Hopefully that's nice and big enough for you. Now in this case, we're given a trigonometric equation. Now we're given a constraint. And these are very important to being able to making sure that you understand the trigonometric relationships for sine. And remember, sine of some angle is just a comparison of the opposite side of that triangle compared to the hypotenuse. So we know the opposite side, we know the hypotenuse, we know to evaluate the rest of the 6 trigonometric functions, we just need to find the adjacent. The problem is we're given cotangent of theta is less than 0. So what, again, we're going to want to do is kind of draw this triangle to see what this is going to look like. So what we talked about was when we talked about drawing triangles now in a Cartesian coordinate system. Rather than just drawing a triangle randomly, if we draw it on the Cartesian coordinate system, we can look at the side lengths in terms of like x's and y's and realize that cotangent is going to be negative only in the second quadrant as well as the fourth quadrant. So keeping pace with drawing these triangles with our central angles at the origin, we have these two options. So we either have this triangle or this triangle. And as I go ahead and draw this, 3 over 5 and 3 over 5, we realize that this is not the right triangle. This one does not work because if you're going 3 units down, that 3 needs to be negative, right? So therefore, that doesn't make sense. Now, the other thing I want to do is I'm going to use Pythagorean theorem here. Hopefully, you guys already know that this is 4, but the Pythagorean theorem is going to confirm why this needs to be negative 4, because actually it's 4, but it's going to the left, right? So we need to talk about direction, not just measure. But let's just do the Pythagorean theorem here real quick, and you can see why that comes up, because we didn't have to deal with it before because we weren't dealing with any kind of direction, and I'm just going to call this x squared. So therefore, I get 25 is equal to 9 plus x squared, and therefore you're left with 16 equals x squared. So now when I go ahead and solve, remember when we introduce the square root, you have to include the plus or minus. And we've kind of like gotten away from that a little bit because we were always using the Pythagorean theorem to find the hypotenuse, right? So we didn't really worry about the plus or minus because the hypotenuse is always positive. Well, now when we're finding the side lengths, direction matters. And since we're going towards the left, this value needs to be represented as a negative 4. All right, so here we have our theta, which is our central angle, and now let's just go ahead and evaluate the 6 trigonometric functions. So I'll have sine of theta is going to be 3 over 5. Let's see, we have cosine of theta, which would be negative 4 over 5. Tangent of theta, which is opposite over adjacent. Let's do the reciprocal functions. This one's easy because we have no radicals, so that's 5/3. We have secant of theta, which is equal to a negative 5/4. And then the best part, what we can do is again confirm that our cotangent has to be less than 0. And obviously, cotangent is negative 4/3. It's less than 0. We made sure that we did that correctly. Why does... All right, so let's go on and look into our second example. Here, the tangent. Now, this one's pretty good because we don't know really where this negative should be applied, right? We know that the tangent is opposite over adjacent, but the negative doesn't go up to the top or the bottom. So, like, where does it go? Well, first of all, it doesn't matter forget about this constraint because, again, negative 4/2 is the same thing as a 4/-2. But this constraint is really going to help us determine where that should go. So let's go ahead and draw our possibilities for when cosine is negative. Cosine is less than 0. That means it's negative. So cosine is less than 0 when the x coordinates are going to be negative. So our central angle triangles are going to be here and here. And so there's our theta. There's our theta. Well, obviously, if you're dealing with the third quadrant, that means the x and the y coordinate are both going to be negative. That's not going to work, right? We need a triangle where only one term is negative because it is very important for you to understand that this does not equal negative 4/-2. So this negative is only going to go in the numerator or the denominator. So since I'm going to the left, I know that this needs to be a negative 3. Has to be a negative 3 because the next triangle I have to go up is a positive square root of 3, right? So that'd be a negative 3 or square root of 3 over negative 3. Because if I did it down here, it'd be a negative over negative, which would make that a positive. So this is going to be my correct triangle. Now I'm going to use the Pythagorean theorem. I'm finding the hypotenuse again, so therefore I don't need to worry about the plus or minus. But let's go ahead and figure this out. So square root of 3 plus negative 3 squared, let's call it again r squared. So that would be 3 plus 9 equals r squared. And that's going to be 12 equals r squared. And square root of 12, we can simplify that to be 2 radical 3 equals r. Okay. So now let's just go and evaluate our 6 trigonometric functions. So again, here's our central angle. So we'll have sine of theta is going to be opposite over adjacent. So that's going to be square root of 3 over 2 radical 3. Square roots divide out, and you see you're just left with 1/2. Cosine of theta is going to be adjacent over hypotenuse. So that's going to be a negative 3 over 2 radical 3. And if we just rationalize the denominator here, we're left with a negative 3 over the hypotenuse. So if I rationalize the denominator, I'm left with a negative 3 square root of 3 divided by 6. That simplifies to a negative square root of 3 over 2. And some of you might recognize these side lengths and say, oh, I actually kind of remember these coming up. And that is because they are special right triangles again. So in this case, tangent is going to be negative square root of 3 over 3. I'm going to do the reciprocals down below because I have some more space. So the cosecant of theta is just a reciprocal of sine, which is 2 over 1, which is 2. The secant of theta is going to be a negative 2 over radical 3. When you rationalize the denominator, you get a negative 2 radical 3 over 3. And then the cotangent is going to be a negative 3 over the square root of 3. Rationalize the denominator, and you get a negative 3 square root of 3 over 3, which is just equal to a negative square root of 3. So I'm showing a little bit of work, but hopefully you guys are kind of following. Again, this is not like an introductory here. This is like our third day kind of going over this, so I don't want to spend too much time on that. All right, so on this last one here, basically what we're going to be doing now is, again, looking at this, trying to create a triangle. And remember, the cosecant is a relationship of the hypotenuse over the opposite. So the problem is we don't have a ratio here, right? We just have a number. We just have negative 4. So what we can do, though, is we can write this as over negative over 1. But this gets confusing because then that makes us look like negative 4 is our hypotenuse and 1 is our opposite. Well, it is, the values are there, but the sign, we know that 4 can never be the hypotenuse, but negative 1 is our opposite, all right? So when we sketch our triangle now, secant has to be positive, which is the same thing as, remember, the cosine, right? So cosine and secant, since they both deal with x, they are going to be negative in the second and the third quadrant, and they will be positive in the first and the fourth. So my two options are here. Well, since my opposite side has to be negative, this triangle doesn't make sense, right? Because this is in the first quadrant where everything is positive. So I'll have a negative 1 here, and this will be a 4. Let's go ahead and find the x. So I'll just do a nice little Pythagorean theorem again. 4 squared plus negative 1 squared. Oops, sorry about that. That's the hypotenuse. So it's 4 squared equals negative 1 squared plus x squared. All right, so 6 squared is going to be 16 is equal to 1 plus x squared. Now we're subtract, so we get minus 1. So we'd say x squared is equal to 15. And now when I take the square root, again, you got to confirm that plus or minus, but since we know that this triangle here is in the fourth quadrant, x is going to be positive. So we're just going to deal with the positive value of square root of 15. All right. So now let's go and wrap this up, and then I will go ahead and take some kind of questions, check in with you guys as we're getting here. I don't have too much time, but hopefully can wrap this up. So sine of theta in this case is going to be, let's see, opposite over hypotenuse. Oh, we already have sine of theta. Well, the sine of theta is the reciprocal of cosecant, so that's going to be negative 1/4. Did I write these down when I could have? Yeah, simple. Cosine of theta is just going to be the adjacent over hypotenuse. So, I'm sorry, yeah, adjacent over hypotenuse. So that's going to be the square root of 15 over 4. And the tangent of theta, that's going to be the opposite over the adjacent. And if you rationalize the denominator, negative square root of 15 over 15. So the cosecant, we already know that answer. That was given to us, which I forgot to do for the other problems, which is like the easiest thing to do. So that's negative 4. The secant of theta is the reciprocal here, so that's going to be 4 over the square root of 15. You're going to want to rationalize the denominator, and you'd get 4 radical 15 over 15. And then cotangent of theta is the reciprocal here, which is just going to be square root of 15 over negative 1. So that's going to be negative square root of 15. All right, so what I'm going to do is I'm just going to take a quick little break. I only have about 10 minutes left here to go through. But if you guys want to kind of take a look at some of the multiple choice, I think I got 3 of them I'm going to work on. Yeah, I got 3 of them I'll go through. So we'll cover these 3. But before that, I'll just kind of check in the chat with you guys, kind of see if you guys have any questions or if there's anything I can do to kind of help you out or if there is anything on mine. So what game is this? Not just checking in chat. See, it looks like my live. Man, I don't know what's checking there. I guess I'll just go and see even on the Facebook stream. Not sure. Guess it's not pulling. Oh yeah. Okay. Cool. Yeah. Well. Goodness. Yeah. So cool. It is came through, but yeah, it looks like on the. Oh man, the Facebook. That's a really bad live. I'm not sure why that is. So either way, cool stuff. Well, all right. So let me just go and finish this up. I can see obviously I got the chat, from you guys, and if you guys do have some questions, then let me know. I'll be happy to. So Vita says, I have no idea what's going on here. Well, that could be true. I mean, depending on where you are in your class or what class you're taking. This is for my pre-calculus class that we cover, and we are in our 3rd day of covering in trigonometry. So we've kind of talked about the sine, cosine, tangents. Then we talked about the angles. And basically we kind of brought them together for this lesson. So that's what's going on there. And then today, which was the next lesson after this, is we're now talking about like the unit circle and so on and so forth. So that's kind of been the progression. But, again, I have no idea what class you're taking or what's going on here. So let's go ahead and, wrap this up just so I can make sure that I have, and then I'll finish the stream. And then if you guys have any questions, then I'll just be maybe, happy to kind of answer them for you guys, let you know what's going on. All right. So on question number 1 says, suppose cotangent of theta is greater than 0 and secant of theta is less than 0, in which quadrant could theta terminate? Basically meaning where would the angle of the terminal side be? So I know that cotangent of theta, remember cotangent is x over y. So if it's going to be positive, I have to have them both be positive or both be negative. All right. And then for the secant, if secant is less than 0, remember secant is going to be is basically x or r over x, where r is always positive. So basically I'm just looking for when the x values are negative. So that's going to be in the second or in the third quadrant. And then you guys can see that the only quadrant that both triangles would have to be in is the third quadrant. On question number 2, it says the secant equals 9 over 18. It's in quadrant 4. So we're going to want to remember that is in quadrant 4, find the tangent. So the first thing we want to do, though, if we need to find tangent, remember tangent is opposite over adjacent, and secant is hypotenuse over adjacent. So we need to be able to figure out the opposite side. So let's just draw the triangle in that fourth quadrant, just so we kind of have a visual representation of this. So that would be hypotenuse over 8, again, with our central angle, right? So if I wanted to find the this opposite side here, I just do Pythagorean theorem. Zoom back in. Is equal to 8 squared plus, let's just call this y squared. So this is 81 is equal to 64 plus y squared. Subtract on both sides. And that's going to be 17 equals y squared. So therefore, y equals the square root of 17. But again, visually, it's important. It's not a positive square root of 17, right? Because you got to include the plus or minus. And you can see that since we're going down, that's going to be a negative square root of 17. So the tangent is going to be negative square root of 17 over 8. And that's answer B. And last one is a point on the terminal side of an angle theta is given. Find the exact value of the indicated trigonometric function of 3, -7, find tangent of theta. Okay, so again, we're given a point, right? And when we're given a point, the best thing to do is just plot that point. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So we go ahead and plot the point, and we create our triangle. And again, if we create this, again, as our terminal angle here at the origin, we can see that we're going to have 3, -7. All right, well, the tangent of this angle is -7 over 3, which is answer A. So, boom, there we go, done. Multiple choice answers. Those are awesome. The first half took, much longer than those, so, not too bad. So that's basically it that we kind of covered. Again, just kind of a review of what we did. We really only looked at 2 different types of problems. One, when you're given a trigonometric equation and a constraint, we want to sketch the triangle with the central angle, and then BS will find the missing side and then evaluate the 6 trigonometric functions. And then the other examples that we worked at was given a point. And we're just given a point. We're going to want to plot that point to create, again, a right triangle with a central angle. And then we can evaluate the 6 trigonometric functions. And the big thing also to bring back was direction matters, right? It matters which quadrant your triangle in. It matters if your values are positive or negative. So just be very careful when you're working on that. So, but that's it. I have about 5 minutes here that I can actually try to answer here. So if you guys have any questions back on, it looks like the stream health is back on, so I'm not sure. Maybe that might have been my internet at school. Sometimes that's can get kind of low, so I do apologize for those of you that were trying to jump on and maybe had a lag or just wasn't really coming in clear. It looks like everything has kind of been fixed, so I can't study because of my phone. Super Vegeta, I'm not sure. Do you have a question? Square root of 50. Hard flip, yes. So hard flip is asking me square root of 50 equals 5 times 5 times 2. That is correct. Are you answering somebody else or my question? Arc Fighter, best of luck on your test, man. Hope you do all right. You should stream gaming, be giving people what they want. Yeah, I know that's kind of weird. I'm not sure how many people would be able to transfer over to like getting some help on some math problems to watching me game. It's I don't know. I mean, I guess possibly, but I mean I know that's definitely something that people would be interested in, but I'm not sure basically for me myself. So XPlay Markers asks, hey, I love your videos. Have you been a great help for me? Do you have any advice for memorizing and solving trigonometric identities? We haven't gotten to identities yet. So, I mean, I'll tell you a lot of the same things that you probably might already know, that is taught. But, I think the main thing is when you're like verifying identities, make sure you just, pick the complicated side, right? So you have an identity. You have one side and you have the other side. Always start with the one that's the more complicated. So that's usually a kind of like an idea of like, oh, this one has a lot of, addition, subtraction, multiplication, whatever. Start on that side. The next thing is to apply operations. If you see something where it's like addition, subtraction, or a rational function where you could rationalize the denominator, or something that is a quadratic and you could factor it, apply your operations. Whatever operations you see, look to apply to them. The next thing is look for those Pythagorean identities. Those are really, really important. And a lot of times those are what will trump a lot of students up. So look to apply the Pythagorean identities. Obviously, all the identities you can look to apply. But, a lot of times I look at, when I see that terms are squared, I'm automatically thinking the Pythagorean identity is possibly going to come into play here. And then the other thing, again, I'm kind of writing this really small and really sloppy, but the other thing is just, it's easy to just convert to sines and cosines. That's okay. And again, these are just always tips. They're not going to work for every problem. But I love identities and I love getting stumped on identities. And, really to give you the best advice, it's just practice. It's just practice a bunch of the problems. Because the more you kind of practice, the more kind of you see what works and what doesn't work. And, I've really felt that even with all my practice, I'll still get stumped on, trying to verify an identity. So, a lot of these tips and tricks kind of help and they work, but, I think the main thing is just really getting some practice and you will start to feel a lot more confident, so hopefully that helped. I can't remember what I mentioned. So, you should stream gaming. What does 5 square root of 50 equal 1 square root of 2? Not to go off the subject, I understand. Heartfelt Mike, I guess, you kept on asking that again. So, I'll break down this square root of 50 for you. Heartflip, I'm not sure, or Mike, I'm not sure if this is like what you're asking, but there's kind of two different ways you can do this. You can break this up into the prime factorization, or, what I just prefer to do is think about numbers you can take the square root of. Like, we know the square root of 1, we know the square root of 4, we know the square root of 9, we know the square root of 16, we know the square root of 25. We know the square root of 36, the square root of 49, and the square root of 64, and that list goes on and on. But we don't know the square root of 50, right? So that's a problem. But what we can do is, can we rewrite the square root of 50 as a product of one of these numbers that we can take the square root of? And yes, we can rewrite it as the square root of 25 times 2. Right? And again, this works is because by the rules of radicals, you can do the square root of 25 times the square root of 2. So now I can separate them under their own radical, and now I know the square root of 5. That's just 5, radical 2. So it kind of depends on where you're at in your math. A lot of times we also do like the prime factorization way, like if you can just break it up into, say, okay, 25 times, 2, and then you can break that up into 5 times 5. Times 2, and then rewrite it as a prime factorization. And again, the idea of the square root is if you can take a grouping of them, multiply by each other, you can take them out. So therefore, it's 5 square root of 2. Kind of the same idea, a little different process. This is a little bit more elementary, and this one's kind of just making sure you understand the rules of radicals. So hopefully that helps. I didn't know if that was what you were looking for or not, but and then I didn't see you posted as far as your answer. So Apologize for that. I know the answer. Oh, thank you. Awesome. Any of these unknowns you can substitute into the original equation. So, not sure what else you guys have. So I can study because of my phone. What is back substitution method? Okay, so thanks you for awesome. Turning it back into the equation which solves the unknown variables. Back substitution method. Yeah, I guess going back and checking your answer. So, all right, guys. Well, I will be back tomorrow. Looking into probably doing a stream again around the 3 o'clock time frame. So, if you're not sure if you're going to be here, but you want to be notified, obviously you can go ahead and just hit the notification bell and subscribe, and obviously that will let you know. But otherwise, I'll look forward to seeing you guys back on next live stream. We're going to be talking about the unit circle. So, I'll go over some homework problems as far as how to evaluate our trigonometric functions using the unit circle. So, hopefully, I will see you guys there. All right. Cheers.